Okay, let's dig into this. We're looking at the Model Context Protocol, MCP. It's basically the groundwork for these new general AI agents we're seeing.
Right. It standardizes how LLMs talk to everything else, tools, APIs, databases, you name it.
It's like their digital hands and feet, giving them a way to interact with the world beyond just text.
Exactly. And, well, our mission today is to really stress test that foundation using MCPMark. It's a benchmark designed specifically for that.
To push these agent
Oui.
capabilities, right?
Okay.
To see what they can actually do in complex situations.
Precisely. Because, the older benchmarks, they just weren't cutting it. Too shallow.
Mostly read-heavy stuff, or just single actions.
Yeah, they didn't capture these longer multi-step workflows that you see in, well, real-world use.
So MCPMark is different. How so?
It brings 127 really high-quality tasks, and they span 5 key environments. We've got Notion, GitHub, the local file system, PostgreSQL, and even web browsing with Playwright.
5 distinct areas, and it's not just about reading information.
No, not at all. The focus is much broader, covering CRUD operations, create, read, update, delete. That's the language of actual applications.
Okay, so creating these tasks must have been quite involved. This isn't just throwing prompts at the wall.
Definitely not. Each task starts from a carefully set up initial state. Think of it like a realistic starting point in an application.
And crucially, there's automatic checking.
Yes, a programmatic script verifies the outcome automatically. The agent can't just, claim it finished. The system checks if the database was updated correctly or if the files are right.
That validation is key. And how are the tasks themselves developed?
It was actually a pretty interesting human-AI collaboration. You had domain experts working alongside language agents.
Really? So iterating together.
Yeah, designing, refining, making sure the tasks were realistic, challenging, but also, importantly, verifiable. It ensures the complexity feels genuine, not artificial.
Let's walk through those 5 environments then. They really show the range of difficulty. Maybe start with the remote ones.
Sure, so first up is Notion. Here, the agent has to use the official Notion API.
Okay.
And that means creating documents, editing them, querying databases, sometimes quite complex stuff like updating properties nested deep inside a database structure.
Right, not just surface level changes. And then there's GitHub. I imagine that's a tough one.
Oh, it is. It uses the GitHub Remote API for, well, pretty intensive project management and actual Git operations.
Like what specifically?
Well, take the linting CI workflow example. That's basically asking the AI to manage a whole mini project, create branches, change config files, manage commits, and then open a pull request that actually, works and passes checks.
That sounds incredibly complex for an AI agent. Definitely sets a high bar. Okay, what about the local services? They interact differently, right?
They do. We have the file system. This involves local file stuff, reading, writing, organizing directories.
So like managing files on a computer.
Pretty much. A task like contact information extraction might involve pulling data from different file types, then creating a clean, standardized CSV file.
Okay. And the database side?
That's PostgreSQL. It's all about relational database access. The agent needs to figure out the schema first, then run often multi-step SQL queries. Think employee project tracking tasks.
And so exploring the database structure and then acting on it. Got it. And the last one, the browser. Playwright.
Right. Playwright simulates web browser automation, so navigating websites, filling out forms.
Tricky stuff for automation.
Very. The example they give is the Cloudflare Turnstile Authentication Challenge. That's like a modern CAPI TCHA. The agent has to interact correctly with a dynamic web page, a huge hurdle.
Okay, the complexity is definitely there. So the big question, how did the top models actually do on this stress test?
Well, the main takeaway, MCPMark is hard, really hard.
How hard?
The very best model, GPT-5 Medium, only achieved a 52.56% success rate on its first try. That's the pass at one score.
Just over half.
Wow.
And other strong models.
Models like Claude Sonnet 4 and others, they were generally below 30% pass at one, struggling quite a bit.
50% for the best. That does sound low for state-of-the-art. It really underscores how tough this benchmark is, doesn't it?
Absolutely. It's the depth of interaction required. I mean, look at the numbers.
Yeah.
On average, agents need about 16 execution turns and over 17 tool calls per task in MCPMark.
16 turns, 17 calls. That's a lot of back and forth.
It is. Compare that to, say, live MCP Bench, which needed maybe 3 turns on average. MCPMark demands complex planning and sustained action, and, well, models aren't consistently delivering that yet.
Right. And to measure that consistency or lack thereof, the study uses a few key metrics. You mentioned pass at 1,
Mm,
the single-run success.
correct. Then there's pass at 4. This gives the model up to 4 independent tries. It acknowledges that sometimes, a model might get it right on the second or third attempt.
A bit more forgiving,
Yeah.
but then there's the really strict one.
That's pass 4, the ultimate consistency test. A task only counts if all 4 separate runs succeed.
Every single time.
Yep. It's designed to tell apart models that just get lucky sometimes from those that are genuinely reliable.
Okay, let's break down the performance. There was a difference between the environments, right? This environment gap.
Yes, a significant one. The local services, PostgreSQL, file system, Playwright were definitely easier for the agents.
Easier how?
Well, GP5 Medium, for instance, got up to around 76% success on PostgreSQL tasks, which makes sense, right? These interfaces might be easier to simulate. Maybe there's more training data related to them.
More familiar territory for the models.
Kind of. But the remote services, Notion and GitHub, they remained the real challenge. Most models scored below 25% pass at 1 there.
So interacting with those external, maybe more complex or corporate-style APIs, that's where they really struggled.
That's where the generalization ability seems to fall short. And this gap really highlights the importance of that robustness metric, pass 4.
How so?
Because while giving models 4 tries, the pass at 4 score did boost things significantly. GPT-5 Medium jumped to nearly 70% overall.
Okay, big jump.
But the moment you demand that reliability across all 4 runs with pass 4, the scores just plummet.
Plummet how much?
GPT-5 Medium dropped way down to about 34%. And Claude Sonnet 4, barely 12% pass 4 success.
Wow. So they can succeed sometimes, maybe even often, with a few tries, but being consistently reliable. That's the issue.
That's the core instability problem this benchmark surfaces so well. They're just not consistent workers yet.
That's a critical finding. Did anything else stand out about performance patterns?
Yeah, something counterintuitive.
Yeah.
Spending more, like using a higher cost model run, didn't necessarily mean better accuracy. Some lower cost runs actually got better pass at 1 scores.
Interesting. More expensive doesn't always mean better. And what about efficiency? Does just trying harder, taking more turns help?
Not necessarily. The results suggest that more turns don't automatically lead to success.
So brute force isn't the answer.
Right. The stronger models, the ones that did better, succeeded because they made better decisions, more targeted exploration, not just blindly trying things over and over.
Can you give an example?
Sure, look at a model like Kimi K2 Instruct. It often averaged over 20 turns per task. Sometimes it got stuck in this overcalling mode, just repeating tool calls without getting anywhere.
Spinning its wheels.
Exactly. Compare that to GPT-5 Medium, which got the best pass at 1 score, but used a much more reasonable number of turns. It was more focused.
So it really comes down to planning ability, especially for those difficult remote tasks.
It seems so. And there's evidence that giving the models more, let's say, reasoning effort helps.
How do they test that?
For GPT-5, they compared low, medium, and high effort settings. Medium effort significantly boosted the pass at 1 score compared to low.
And did it help more on certain tasks?
Yes, particularly on GitHub, performance there nearly doubled for GPT-5 between low and high effort.
Doubled, okay.
Yeah, which suggests that more reasoning helps the model generalize better to handle those tricky, perhaps less common interaction patterns needed for external APIs.
Makes sense. Okay, finally, let's talk about why they fail. What kinds of errors were most common?
The majority, interestingly, were what they call implicit failures.
Implicit failures, what does that mean?
It means the agent thinks it completed the task, maybe the process runs without crashing, but the final result is just wrong. It fails the automatic verification check.
So the agent reports success, but it actually failed to achieve the goal correctly.
Exactly. It's like it drove the car perfectly fine, just off a cliff instead of to the destination. And these are dangerous because they're subtle.
And these were the most common type.
By far. For some models, like GPT-5 High, over 80% of failures were implicit. It points to underlying flaws in planning or understanding the task nuances.
Rather than just technical glitches, what about those? The explicit failures.
Those happen too, things like hitting the context window limit, running out of allowed turns, or making badly formatted API calls. Less common overall, but still present.
Like the model getting stuck in loops.
Yeah, Kimi K2 Instruct, for example, hit the turn limit quite often, usually because of that repetitive tool calling behavior we mentioned earlier.
Okay, so wrapping this up, what's the big picture here?
Well, it's clear MCPMark does its job. It really surfaces the key hurdles for today's AI agents. Stability, generalizing to diverse environments, and handling complex multi-step planning.
These agents can do amazing things sometimes, but this benchmark shows the reliability just isn't there yet for complex, real-world workflows.
Precisely. And that huge gap between pass it 4 succeeding within a few tries and pass 4 succeeding every single time is stark.
That drop really is the main story, isn't it?
I think so. It leaves you wondering, if an agent can get something right maybe 70% of the time given a few shots, but less than 35% of the time reliably, how do we even measure its actual capability? What does it mean for an AI to know how to do something if it's so inconsistent across runs? That volatility is something we really need to get a handle on.